Hi, everybody. I am Sarah Groff-Palermo. I have a lot of names, so you can also just find me under Sarah GHP. I exist on the internet, in case you're curious. Oh, yes, I exist on the internet. I was not listed with a company. I work at Kickstarter. Today was my very first day, so I am an engineer there. I have a background in critical theory and design, particularly data visualization, which is relevant to this talk, because my talk is called Label Goes Here. It really unites all of these concerns. It's a talk about using diagrams, and we're going to talk about using diagrams for communicating about programming with other people, and also for communicating about programming with yourself. So I'm going to do a little bit about the choice of terms in history, and then some stuff about documentation and learning styles, doing it for ourselves. Data Monster, which is down here, is a project I worked on, so I'll show you some documents from that. And then we'll talk about a couple questions to ask yourself and some other good places to look for inspiration. So let's jump in. Diagrams, right, pretty much encompass charts, schematics, graphs. When people say diagram, they kind of mean all of those things. Mostly, I'm going to be talking about chart-style diagrams, boxes and arrows. I want to keep using the word diagram, though, because I think it's really important to realize that what all of these things have in common is that they're about relationships between various entities, and that's what's important. That you can look at things and you can understand how they're related. And so using diagrams, I think, is really an important term to use. Some of the earliest diagrams, in fact, these are Euler's logical diagrams, are all about the relationships between sets, right? They're all about logical relationships. This is what led to Venn diagrams. And diagrams also may look like nothing that you expect at all. I don't know if this is familiar to anybody. These are Lynn Clark's cartoons about redux and flux. This is from the redux thing. But essentially, this cartoon is a diagram. It's a diagram with characters and a really good story, so you remember what all the different pieces are for. But that's a diagram just as much as this one from Francois Bonnefoy is a diagram. They're telling you the same thing. And diagrams are a cool way to communicate. They use words and pictures, which most importantly means we don't have to translate back and forth. I don't know if anybody is familiar with this. This is Euclid's Elements of Geometry. And it's a really awesome book because instead of having to look up all the different angles and triangles and jumping back and forth when he's trying to tell you something about geometry, it's really clear which elements he's talking about, and you can put them together. They tend towards a high level of abstraction, the forest level, and this can help us generate insights about general organization. They can help us learn to use tools, and they can help us see whether the choices we've made are the choices we thought we were making, and look at it in a holistic manner, which is really useful for refactoring. But we're going to start off with design for documentation. And I don't know if anyone else here has this problem, but I get really annoyed when I'm like interneting around, like reading about an API or trying to learn a new library. And all I can find is like tutorials, and there's no way for me to see how the whole system works, right? It drives me crazy. So like say there's this really cool library that somebody wrote to connect P5.js with hardware called P5bots, and you wanted to learn how to use it. And all you see, excuse me, are all of these words. But really, what you want in your heart is this. You're like, what is it for? How do they connect? Where do I put my files? If you're like engineering students studied by Richard M. Felder, 60% of you are like, what? No, I'm totally cool with tutorials. And the other 40% of you are like, oh my God, yes, please give me diagrams. And that's because this is a very particular learning style that he studied along with Barbara Solomon, which is called the global style of learning. And it's part of this little set, which if anyone is familiar with Myers-Briggs, it might look really familiar because it's essentially Myers-Briggs for how people like to learn. And the one that I'm most interested in is global versus sequential. But of course, there's visual versus verbal, which I think sort of speaks for itself. Do you like to see pictures? Do you like to hear talking? Intuitive versus sensing is pretty much the same as Myers-Briggs. So that's like, are you interested in facts or are you interested in sort of relationships? And active versus reflective. Do you just like to jump in and start banging on things, or do you like to think about it all first? And much like Myers-Briggs, of course, nobody is one thing or the other. There's a link at North Carolina State where you can test yourself and see where you fall on the spectrum. But so sequential learners, which are the global learners complement, they learn by taking small bites of information and putting them into practice, and they're super comfortable with incomplete knowledge. And that's who tutorials are great for. Like, just start typing this thing, and eventually you'll figure it all out. the global learner, though, really struggles to know what to do with facts without a framework in which to slot them. Or, as one of the questions on the test goes, I'm totally prejudicing their results now, is to say that, when you understand all of the parts, do you understand all of the thing? Or when you understand the whole thing, you can put the parts together. So I think you can see now that including diagrams by default into your external-facing documentation is really a kindness to the global style of learner. By giving her a general view, you make the specific points easier to relate, and they really suit the intuitive and visual kinds as well. So this is a really great diagram, I think, that shows what a good diagram is super wonderful at. It's about cubism and abstract art. And you can see, right, that it gives us a really strong sense of the relationships between different movements in Europe in the first part of the 20th century. You can find outliers really quickly, like Fauvism, for some reason, has so many influences. Fauvism was just like, what is everyone doing? I'm gonna do that. Versus like Cubism is like, I don't care what anyone else is doing, but was super influential. The machine aesthetic is like influencing everything in like 1915, 1920. They're like, holy crap, we've got railroads. This is amazing. We should make tons of art about it. And then you can drill down into more specific relationships. You can look at the cities where different events occurred. You can look at the years, and you can start, putting together some theories. If you wanted to research geometrical abstract art, you know where to start and how to go all the way back. It's a great diagram. And it's certainly much easier to get information out of than this paragraph here, which has perhaps a third of the info, if not less, just about Cubism itself. And this sort of style of looking, which is overview first, zoom and filter, then details on demand. If anyone else here has done data viz, this is actually Ben Schneiderman's, his mantra of visual information seeking. And it describes the methods that you should be designing for high bandwidth information processing. This is what people do when they have a lot of information in front of them. And that's what diagrams really suit. And another reason I think that thinking a lot about global learners is, in general, the more non-traditional developers I know, so people like me who maybe came from design and English, people who just didn't come straight up through math into CS, are very often these global kinds of learners, and it takes them a little while to start doing computer science and programming, and then they're like, oh, this is just a big system, and I understand where everything goes, and it's amazing. And so reaching out to people like that, I think, is just good for us in general. Like I said, about 60% of the engineering students that Felder studied did like sequential and active, and it really focuses on one kind of learner, but I think it suits all of us to reach out further. And now, since you know it's awesome, you know you should be using it internally too. Unlike the external ones that you might spiff up at the end, internal ones should be super lightweight. They can be partial. If you have a really standard repo setup like this is P5.js, you don't have to diagram the relationship between test and lib and source if you're dealing with people who know convention, because why bother, right? But there's other cases where the setup of it is the thing, and it's funny because this is about Webpack, so we had our synergy. We didn't even know. This is a project I did with the Office for Creative Research, which is a data viz studio in Brooklyn that does a lot of science work. This is for elephants, which is. And they came out with an elephant atlas, Paul Allen's work in Africa counting elephants. And so when we were first starting to work on this project, we just needed to do a bunch of different prototypes. And we wanted to use React, and we wanted to use Webpack. And everybody was kind of scared of React and Webpack, so we hadn't done it before. And it was like, oh, this is so hard. There's all this stuff. And it was a bunch of mid-level devs who were comfortable programming, but didn't necessarily understand how everything fit together. And so this is actually at the top of our README for that repo that I put together. And it was really helpful to say, this is what Webpack is doing. If you get an error here, this is what's feeding into what. This is where you can start looking, and you're not sort of beholden to a stack trace, which may or may not even be pointing to where the problem is. And so it was really helpful for us. You can also stick it in code itself. This is made by a friend of mine, Brendan, which I'm super, here, I'm gonna move so everyone can see that. I love this so much that I'm like, this is the best comment. How do things move through the files? How do they, how does each agreement work? What phase goes into what phase? It's super clear, and I love it. And so that brings me into diagrams for ourselves. So I find them really useful for figuring out what past Sarah and future Sarah have been up to or will be up to. Often I have no idea what past Sarah was doing. So this can take place before you start to code using diagrams for planning, and it's super useful to do because now you're just going to like make one for planning, and then you're going to make it a little nicer and put it in your repo or in your code for everyone else, and you're going to make it really nice and share it with the outside world when you get there. And they can get really UML-y and crazy, but honestly, like my favorite way to do it is just to grab my notebook and some markers. So this is one of the first diagrams I made for my Data Monster project. And Data Monster is a domain-specific language that transpiles to D3.js. D3 has a lot of boilerplate, and I got tired of writing it or copying and pasting it. And I was at Recurse Center, and I was like, this sounds like a fun project. I should definitely write a parser and do weird stuff. So. Right, and so you can see that here, this is like the very first step. I'm just asking lots of questions, and there's like a general pipeline in there, and I'm like, okay, I think I know how this is all gonna work out. Spiffed it up a little bit more so that every day when I like opened my notebook and started working, I could be like, okay, what am I working on? You can see I've got some nice little like colored squares up there to talk about my little loops, everything I'm gonna map over, some colors. I'm like, okay, I know where I'm going. And then it's time to code. And once you've sort of dived in and lost yourself in putting together all the code, making diagrams for refactoring is great. It's actually my favorite part. And it makes me always think about being a person who likes dynamic programming. Like, I know everybody loves types now, and like types are useful for stuff, but I would rather just do something and get it out there, right, and see it and maybe have it blow up in my face than argue with a compiler all day. And I feel like that's sort of what happens when you code. You're like, I'm just gonna get all this stuff down, and then I'm gonna find out what happens. And so when you find out what happens, I think that's where the diagrams really are like the secondary side. Instead of writing all my types at the beginning, why do that? Compiler is smarter than I am. I'll let it figure it out and draw some pictures. And so then I can find out where I've made a mistake. So basically, the way that the pipeline works for Data Monster is I get user code, I parse it, I get an AST, the interpreter gives me an intermediate representation, and then at the end, the writer file writes out just the transpiled JavaScript string. It's pretty straightforward. It's a nice structure because, like, if once upon a time people had gotten super into it but hated the first half of it, you can, as long as you can generate an intermediate representation that looks like what it wants, you can do anything with it. So I set this all up. And so this is a diagram of how the interpreter file works. This was my, like, waking up from a coma being like, holy crap, what did I do? And you can see, right, like right there, you can see much more clearly than perhaps in anything else, like I've done something terrible. There's like a rat's nest there, and like why is everything all linked together? I have no idea. There's a super tight coupling between generating all of these elements. I have two functions that everything is calling, and they're called handle siblings and add children, which is weird because if everything's calling it, are they parallel? Are they doing a really similar thing? Should the name reflect that? But it's really clear that something crazy is going on. All of them are adding something to a structure up here. This was before I had done a lot more functional programming. And like, really what this tells me is I just need a pipeline. That if everything is this interrelated, it's silly to be calling them back and forth. And like, a nice pipeline is probably a better way to deal with it. I can also see that I'm calling these functions, which are called, we have convert to defunc and convert to func, which is ridiculous, right? And you can see up there, the defunc is only being called once. And then everything else is calling convert to func. So maybe that's a sign that I should probably be doing something else, that I was working and I was like, oh, I need this other function, and I didn't realize how much I was duplicating. It also looks like maybe this is the start of a utilities function section. Maybe there should be more stuff there and it should be rewritten, but it's worth sort of looking at. And finally, looking at both the writer and the interpreter files, I can see that I'm doing like these very specific calls in two different places. And for DSL, having 5 or 6 really specific functions isn't shocking. It's like I'm doing the thing I always have to do, so we may as well make that a special choice. But maybe they shouldn't both be in both files, and I can look at those together and fix it. And so I did this within 2 weeks, probably. I wrote the code, I diagrammed it out. I rewrote the code. It's much nicer than this now, although it's still about 2 years ago, so it's probably not as nice as newer code. And the thing is, though, right, I use it to immediately make changes, but there's so much more possibility for holding on to diagrams and continuing to keep them up to date 2 months or even 2 years later as you're working with people. by doing the work and not even auto-generating it, but going in and updating your diagrams, at least internally with people you're sharing systems with, it keeps you honest. You can see where you're diverging from the structure, and you can consider whether that's what you want to do. And sometimes it is. Sometimes things come up, things change. You want to change them, but you can be very determined about it. And so altogether, I think a diagram can serve as a really great internal and external documentation and as an item for thought, and a way to really look at what you're doing in a different way. So, given all that, I hope you guys are really excited now to like go back and make lots of diagrams. Also, something I didn't even include in here, but like, you can make diagrams with pens, and it's really nice if you're typing all the time to just be like, screw all this, I'm gonna sit down with my notebook and some markers. Get yourself in a different way of thinking. But you might be saying, how am I gonna do this? And like I said before, it's super, and you guys have seen my examples, it doesn't have to be complicated. You don't have to be perfectly logically rigorous when you're putting them together. You don't have to have a really complicated system. It's just a multimodal way to think and send a message. So a couple good things to consider as you start. I would, once again, always go back to Schneiderman's mantra. Overview first, zoom and filter, then details on demand. As long as that's sort of what you're aiming for, I think you'll be starting in the right place. Then you might want to ask yourself something like, which relationships are important? What do you really need to show? Do you need a file hierarchy? Do you just need to be showing the interactions? And related to that is what you want other people to take away from it. So back with the elephant diagram, really the most important part of this whole diagram is like where your JavaScript files go. And I think one of the flaws of this is it doesn't do, I mean, it has an exclamation point, so you know it's kind of important. But it would be better if I called it out more with color, with other emphasis, but just to make sure that everybody knows what's going on. Be representational if you want to be. Having an icon set is really nice. You can get free or cheap ones, right, on the internet. And it's nice to be able to be like, these are servers. You all know what like the standard server cylinder looks like. So go ahead and do that. But don't go crazy. You don't want to have, a legend that's twice the size of your diagram. You can just use notes. And the last thing is, don't do backwards arrows like UML. It's all a lie. They've done a lot of studies. Going from to to is really, really important. And sort of the abstraction of that is, if you are sharing it on a big level, poke around on Google Scholar, look at some data viz papers and what people expect. Be super clear. And so I'm almost done. So a final inspiration that I like is, even more than me being like, here's 4 really good things to think about, is to look at a great example. And there's a book called Thinking Forth, which is about Forth, which is a stack language. NASA likes to use it to land stuff on other stuff. But it was brought to my attention by my friend Justin Falcone, so I have to put his tweet up there. And it's mostly just really, really good. All right, I want to make sure everyone's okay. It's mostly very good at using diagrams and cartoons and labels to tell you a great story about programming. Even if you don't want to write stack languages, it's worth probably reading the first 2 chapters just for a great summary of approaches to program design, through the years too. It's really nice, it's not, everything wasn't invented 3 years ago, and they do a great job of sort of walking through it. And I love how even, you can see from the sequential design to the design by components, how clear those 2 pictures make about the difference between the approaches and their pros and their cons, right? But I hope you guys do that in the future. That's all for today, and thank you so much.
That was awesome. Thank you very much.
Yeah, thank you.
Let's see. So time for maybe 2 or 3 questions. First one for me, if someone's just getting started, so I'm a developer, I haven't spent much time in data visualization, what are the first 1 or 2 resources you recommend I check out?
Now You See It from Stephen Few, I think is very good. I like Stephen Few a little bit better than Tufty. Data viz can sometimes run into, a lot of other programming, people who have lots and lots of opinions, and they think their opinions are scientific, and they sometimes are and they're sometimes not. Stephen Few, I think, is opinionated, but comes from a good place and gives people a really good underfoot. There's a blog called Flowing Data that Nathan Yao keeps up, which is, I think, a really great way to just see what people are doing in data viz.
Cool. Questions? Go ahead.
So I was curious about how you drew all this diagram. Did you just like sit down and just really dump that in your head, or did you have more? They were fairly organized for being like so much stuff on there.
Well, so that's like, I did just do those once, but it's kind of cheating because I was a designer for a very long time. So I've had, I think, maybe a little bit more experience. There's sometimes I will start one and be like, this is messed up and I should stop doing it this way and do it again. I think when you're drawing, especially at home, people are like, oh, I want this thing to be perfect. And like, it doesn't matter. It doesn't have to be perfect. You don't have to show it to people. You can always do it again and throw it away and use pencils. Markers make it fun, so then it's less like, oh my God, did I draw it right?
What do you find most useful, before, during, or after? You mentioned jumping in, jump in first, figure out what works. So do you just build the graphs out incrementally?
I don't. For these, I write them and then I go back to do the graphs. I like being able to switch between the sort of two levels of thinking about stuff. Sometimes if I'm trying to optimize on like 5 levels at once, right, I can go a little bit slower and versus being like, all right, I can pay attention to the details of implementing this function, making sure that it's performant and I'm doing it well and it matches with our style guide and all those sorts of things that I'm doing when I'm typing code, and then being able to step back. But that's why doing one beforehand is good, just a really broad one, so that I don't get halfway down and be like, oh wait, what was my whole plan, right? Like, and that I do tend to, I might mark up a little bit more if I'm like, oh, obviously that was wrong. Yeah.
So, I mean, obviously you drew a lot of those by hand, but what would be, a pretty legitimate tool for creating diagrams for coworkers or
Whatever is cheap and easy, actually. I think Keynote is great. It has boxes and arrows and they're not super hard to use if you don't, there's no reason for anybody to be trying to figure out how to use Sketch or Illustrator or something like that if that's not what you do all the time. Keynote is super good for laying things out. And then sometimes there's other UX software, none of which I can think of off the top of my head, but sometimes there are UX things, but I would use the free thing that I already had over paying for something for charts for sure.
I think we'll call it an evening.
Awesome.
Thank you so much.
Thanks.
That was awesome.